Hello, I'm Daniel from CiES Incorporated. CiES is the world's largest manufacturer of aviation fuel level sensors. Our products are TSO'd and our STC covers over 300 different applications for fuel sensors, fuel senders, fuel probes, fuel floats. Call them what you will, but all of them have their own unique fitment and wiring requirements. With this vast lineup, we have found some common hang-ups with customers during the ordering process, as well as during the final installation and calibration. Let's start with some basics about our design and how our technology works. Float-based fluid level measurement devices have been around for over 100 years. However, the heart of our design is the circuitry enclosed in a sealed machined aluminum housing. On board this unit is a device that measures the polarity of the magnets attached to the float arm, allowing it to read the position to an accuracy of 1/10 of a gallon. Because this device is insulated from the fuel, we achieve a mean time to failure of over 90,000 hours. Wire colors are a common hang-up during installation. Let's start with the two most obvious colors. Black, ground. We need less than 1 ohm of resistance. Some fuel quantity instruments or displays also require a ground reference. You will need to consult the gauge manufacturer's installation manual to check this. Red, power. Full aircraft power from a dedicated 1 amp breaker. Our senders have a functional input range of 9 to 28 volts DC. Blue, digital frequency output. If your fuel quantity instrument requires a Hertz input signal, this is your wire. Those are the 3 wires found on every one of our CC series units, but in some cases more wires are necessary. Green, voltage or analog output wire. This is included on your unit when the fuel quantity display requires it. Dynon and Garmin G1000 are examples of displays that require this additional wire. Gray, secondary input wire. When there are multiple senders interfacing in tandem, this wire will be connected to the blue of the secondary sender. This is common in tanks larger than a 30-gallon capacity, as using 2 sensors is the only way to read the entire quantity of fuel. Orange and red, secondary input wire number 2. This is not very common, but when there are 3 units in a single tank, they require another secondary input wire. There are a few more wires that could be included, but to avoid confusion, it is better to leave them out of this video. If any of these wires are not utilized in your application, you may just cap and stow them separately. Our senders are electronically tested twice before they are shipped, but it's always good practice to bench check the senders before installing them. You can do this test by connecting the red and black wires to a power supply like I have here. There are 3 basic orientations and 4 basic clockings that your new fuel sender can be mounted in. These were designed and determined by the original engineer of the aircraft, and even if they are suboptimal, CiES is required to match them. This fuel sender is mounted from the top of the tank. Notice how the arm has a slight angle bent into it. This allows the float to contact the bottom of the tank without getting stuck. There is also a physical stop built into the unit to avoid further rotation in the wrong direction. This fuel sender is mounted from the bottom of the tank. This is simply a reversed version of the top-mounted configuration. Now the bend will keep the float from getting stuck on the top of the tank. This fuel sender is side-mounted. It has a full range from bottom to top of the tank. The range is only limited by the dihedral in the tank. Any of these senders could be mounted in any direction, right? Well, yes and no. The standard SAE 5-hole bolt pattern may look symmetrical, however one gap between the holes is slightly larger than the others. Notice all these senders. The writing is only correct on one unit. What if I told you that all 4 of these senders are mounted correctly? The clocking is determined by the originally installed senders on the aircraft. They will only fit in one direction. Based on the data that we have matched this fitment, and your new fuel senders will be a physical bolt-in replacement for the antiquated original equipment senders. As you have seen, we have many different configurations. So how do you order them? What information does CiES need to make sure you order the correct set? Some obvious questions that need to be answered are, what is the make of the aircraft? What is the model? What is the cockpit instrument that the senders are going to interface with? These answers provide us with around 70% of the configurations we deal with, but in some instances, more information is needed, such as what is the capacity in each tank? What year was the aircraft manufactured? Is the tank a bladder or an integral wet wing? With this information, we can fill in the gaps and ensure that you order the correct set for your aircraft. But what if the aircraft is not listed on our STC approved model list? If this is the case, please reach out through the contact page on our website. Our website also has all the certification documents and installation manuals posted for easy access. If this video answered your questions, leave us a like. If you would like to stay updated on how our technology can enhance your flying experience or make it safer, subscribe. If you have any specific questions about our technology or your application, leave us a comment or contact us on our website. Our website is www.ciescorp.com. Thank you for watching.